calling it neutral. Okay? Now, let's look at some of the salts. A. And what was the first salt? Anilinium formate. I can't even spell. Okay, so I'm taking the conjugate acid of the aniline and the conjugate base of formic acid, the formate, and so Kb is 10 to the minus 10, Ka is 10 to the minus 4. Well, let's just say 10 to the minus 4 divided by 10 to the minus 10. What?
10 to the 6.
10 to the 6. Is that bigger than 100? It's about 1,000,000.
Wait, so what did you do there?
Which I divided which one's larger. The Ka is 10 to the minus 4, and I divided it by the Kb of the conjugate base of formic acid, which is 10 to the minus 10.
Which is smaller.
Which is the smaller of the two. So it is
Much bigger.
it's more than 100 times. It's 1,000,000 times bigger. So Ka for is much greater than Kb, and therefore it's going to be acidic. Because since 10 to the minus 4 is much greater than 10 to the minus 10. Makes sense. It's about 1,000,000 times bigger. So that's where you just want to get a sense for that. Okay, and now B. What was B? Anilinium bicarbonate. And there I've got, where's carbonic acid? 10 to the minus 7 as 10 to the minus 7, and anilinium is 10 to the minus 10. Okay, so anilinium is 10 to the minus 4. 10 to the minus 4 divided by 10 to the minus 7. What? 10 to the 3. It's 1,000. Okay. Again, Ka is much greater than Kb, therefore acidic. And that's because 10 to the minus, what was it? 7 or 4 was greater than 10 to the minus 7. So it was an easy call to make. Okay? Now, for part C, what was part C? Hydroxylonium bicarbonate. Oh, I don't even want to spell it. Okay. Well, I guess I have to. Okay. The hydroxylonium bicarbonate, well, okay. The conjugate of hydroxylamine is 10 to the minus 7. I mean 10 to the minus 6, the conjugate acid. Hydroxylonium, sorry, hydroxylonium is 10 to the minus 7 is the Ka, or 10 to the minus 6 is the Ka. And bicarbonate, the base, is 10 to the minus 7. 10 to the minus 6 and 10 to the minus 7. That's 10. That's too close to call. Okay, so there, Ka is around equal to Kb, and therefore neutral. And that's because 10 to the minus, what was it? 6 is around equal to 10 to the minus 7. That's too close to call. Yeah.
So if the conjugate acid is smaller than the conjugate base and you divide and it's greater than 100, it's basic?
Okay, if it's smaller than the conjugate base. Okay. Yes. Yes, exactly. You take the K for the conjugate. And this, when I try to say it in words, it really starts to sound really weird.
Yeah.
You take the K's for the conjugates, and if you divide the K for the conjugate, whichever K, if the K for the conjugates is greater than a division of greater than 100, then that one predominates. And it doesn't work well in words. It works much better in practice when you look at these numbers, because this is pretty straight up.
Doesn't this basically mean that you'll have a value of K for the acid and for the base?
They're close to each other.
And that whatever one's smaller, you put on the bottom to find the difference.
Yeah.
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 And if the difference is big enough, then you know you.
Then it's going to predominate. But if they're too close to each other, you can't call it. We can't make a qualitative call. And that's all this is about, is making a qualitative grasp of what happens when I make salts of conjugates. And so which one was next? Potassium fluoride. Oh wow, that one's going to be D. Potassium. Well, there I've got K, potassium, is the conjugate acid, although it's only a Lewis acid, the conjugate acid of the strong base, potassium hydroxide. Since it's a strong base, it's the conjugate of a strong, it's too weak to get involved in hydrolysis. Hydrolysis only occurs with the conjugates of weaks, which we've been considering. And so K is conjugate So, since it's too weak to enter into the equation, I've got the conjugate base of hydrofluoric acid. Therefore, conjugate base predominates. And that is, this one's the wordiest of the answers. Therefore, it's basic. I don't know what the pH is, it can be greater than 7. Guaranteed. Take sodium fluoride, potassium fluoride, any of the alkali metal chlorides, and it's going to be basic. Okay. And so now, is that the last one? No. Hydroxylonium, oh I hate spelling these. I hate pronouncing them. Hydroxylonium formate. Okay, so E. And now, I'm going to go back and look at my data. Formic acid, 10 to the minus 10. Hydroxylonium, 10 to the minus 6. 10 to the minus 6 divided by 10 to the minus 10. What? 10 to the 4th. That's 10,000, much bigger than 100. So that means that the acid the hydroxylonium, the conjugate acid of hydroxylamine, is going to predominate. And so Ka is much greater than Kb. Therefore, what's it going to be?
Acidic.
Yeah, because 10 to the minus 10 to the minus 6 is much greater than 10 to the minus 10. Okay? And that wraps that problem.